So as we just discussed, whenever we're naming acids and we have the corresponding anion that ends in the suffix "ide," the way we name it as an acid is we put a hydro in front of the name and then change the ending "ide" to "ic acid." Okay, so we're going to do that rule on all three of these, but as we talked about, the first thing we need to do actually is figure out what the anion is. So that's basically everything except for the H's, or just the one H here, out in front. And so what's left is F minus. Now this is technically a -1 charge, and the reason we know it's -1 is because there's just one hydrogen. Okay? If there were two hydrogens, this would be a 2- charge. Okay? But I know that this is fluoride, and so if I want to name this as an acid, it ends in "ide," so I have to write hydro, and then I'm going to drop the ending "ide" and change it to "ic acid." So this, as an acid, HF, would be hydrofluoric acid. Okay? And again, this is the rule whenever you have the ending as "ide." Okay, let's do the second one right here. So this is HCl. First step is to identify the anion. So in this case, it's going to be Cl-, which is chloride. Okay, so that ends in "ide." So to name this as an acid, we follow this rule because it's "ide." So we start off writing hydro, put the initial part of chloride, but we drop the "ide and add "ic acid." So this would be hydrochloric acid. Okay? Then for a third example, again, we have HBr right here. So first up is identify the anion. That's everything except for the H's. So that would be Br-, or bromide. So it ends in "ide." So again, following this rule, this would be named as an acid, HBr, hydro, and then we have brome. We're going to leave off the "ide" and then just add "ic acid." So HBr would be hydrobromic acid, right? So you might notice that with these kind of acids where you have hydro in front of it, all of these anions, the fluoride, chloride, bromide, these are all halogens. They're in group 7. And actually, for very common acids that actually follow this rule, the anion is actually in group 7 of the periodic table. And so these are all halogens. So we would have hydrofluoric acid, hydrochloric acid, hydrobromic acid, and the one below this, iodine or iodide, would become hydroiodic acid. Not to say you can't have others that follow this rule, but halogens, or halides, I should say, are the most common. Okay, so let's move on now and talk about the second rule. So this is the case when you have an anion that ends in ATE, okay? So ATE. When you have an anion who ends in ATE, all you do is you simply change the ending ATE to "ic acid." So this rule, when the anion ends in ATE, we no longer have the hydro that we had up here. All we have is just the ATE, okay? So let's look at this one. Again, we start off the same way. We identify the anion. That's everything except for the hydrogen out in front. So that would be ClO3-. So it's actually ClO3-. This is named chlorate. So how would we name this as an acid? Well, it would just be chlor. We drop the 8 and then add "ic acid." Okay? Drop the ending, add "ic acid, and so this would be chloric acid. All right? Let's do these other examples. Here we have to identify everything except for the hydrogens out in front. That would be NO3, and this would actually be NO3-, -1 charge because there's only one hydrogen. And this is actually nitrate. Nitrate. Again, this ends in ATE, so I drop the ending and add "ic acid." So this would be nit, and we drop the 8 and add "ic acid, so nitric acid, which actually happens to be one of the 7 strong acids, just like chloric acid. Let's look at this one right here. This one actually has 2 hydrogens, but again, all we do is identify everything except for those hydrogens out in front, and we get this. This is actually SO4, and it's actually 2- this time, because 2- because there's 2 hydrogens. Now this SO4 2- is sulfate. Okay, so this one's a little bit weird. So instead of just simply dropping the 8 and adding ic acid, which would be sulfic acid, for this particular one we have to actually put an extra UR, so it'd be sulfuric acid. Okay, most of these do not follow this rule, but there's actually a couple common ones that do. Sulfuric acid is one of them. There's another called phosphoric acid that follows a similar rule. Most of the time we won't see that. All right, let's look at these down here. So again, same thing, we want to identify everything that's not the hydrogen, so our anion is right here. That's going to be CO3, 2-. Again, it's 2- because we have 2 hydrogens. And this is actually carbonate. So again, what we're going to do is drop the ending 8 and add ic acid. So this is going to be carbon, drop the 8 and add ic acid. And so this is actually carbonic acid. Okay? And this last one, this is not one that you would have seen, but again, if we know what this is, we can tell the acid name. This one is actually called selenate. That's not one of the ones you need to memorize or be familiar with for this course. But again, selenate is SeO4, 2-. Again, the reason I know that is because if I look at everything except for those hydrogens, that would be my anion, and it has to have a 2- charge because there's 2 hydrogens out in front. And again, if I wanted to name this as an acid, it ends in 8. So this would be selen. I drop the 8 and add ic acid. So this would be selenic acid, right? And again, this rule is different from the first one in the sense that you don't have to add the hydro in front. So if it's ide, you do hydro and then ic acid. If it just ends in 8, you just have drop the 8 and add ic acid. All right, so let's actually look at the last rule. And this is going to be whenever we have one of these that ends in ite. Okay? When we have an anion that ends in ite, if we want to name it as an acid, we drop the ite and add OUS, acid. Okay? So first of all, when we do this, we identify the anion. This one would be ClO2, and just 1- charge because there's 1 hydrogen. This is actually chlorite. Chlorite. So that ends in ite. So to name this as an acid, we would drop that ite and add us acid. So instead of chlorite, it would be chlorus acid. Chlorus acid. All right? This one over here, again, we identify everything except for those hydrogens. So this would actually be SO3, 2-. It's 2- because it has 2 hydrogens out in front. This is sulfite. Sulfite. Now, before we go any further with that, remember from what we just covered in the previous rule, we had sulfate. We had to add that extra UR there. We actually have to do the same thing with its ite version, sulfite. So we would start with sulf, but instead of saying sulfus acid, we would have to say sulfurous acid. Okay? So hopefully that makes sense. Again, this is one of those weird ones. There's not many of them, but phosphate and phosphite are the other very common one that you could run into that have this rule. Okay. And our last one right here, again, we identify everything except for that hydrogen. It would be NO2 minus, -1 charge because we have 1 hydrogen. This is actually nitrite. So to name it as an acid, we drop the ite and add us acid. So this would be nitr, and then we drop the ite and put OUS acid. So this would be nitrous acid. Okay? So again, before we conclude this video, I want to just briefly go through the general rules again. Right, so remember, if the anion ends in ide, add hydro in front and then put ic acid. Okay. If the ending ends in ate, drop the ending and just put ic acid. When it ends in ate, you do not need the hydro. Okay. And then finally, if it ends in ite, drop the ending ite and add us acid. Okay? And these are just generally the only 3 rules that you need to have memorized for this course, at least for naming acids. In the next video, we're going to talk a little bit more about naming binary molecules. Okay? So join us then. Please make sure to like this video and subscribe to my channel for future videos and notifications. Thank you very much.